Hi, I'm Darren and welcome to Level Up EE Lab. Well, I've completed the repairs and rewiring of the Viking Adventurer transmitter. How did it go? Let's take a look. It's assembly time, and the first step is to install 5 rubber grommets. The old ones were still a bit pliable, and I was able to remove them without tearing them, but I had new ones of the same size in my parts bin, so I just decided to replace them all anyway. Next up is to attach the new sockets, and right away I ran into a problem. These new built-in sockets don't have the same mounting spacing as the originals. The holes are closer together in the new ones. Now I know I didn't make a mistake here. This is the only style that Belton sells with solder tabs, so this is a predicament. I suppose I could just egg out the holes in the chassis, but that's really crude and I'd rather not hack it up like that. The next best option is to just trim the sockets to turn the holes into slots, so that's what I did. There's still plenty of material left on the socket tabs to be captured by washers, so they'll still be securely mounted. Even the new 807 socket had geometry differences. It's just a little bit thicker than the original. And as luck would have it, that little bit of difference was just enough to make the mounting screws too short. But no worries, I just substituted some slightly longer mounting screws and was back in business. The 3 slide switches were next. They needed a bit of rework before I could install them, which started with stripping off all the old wires. I also took them apart for internal assessment. This one here has 2 contact discs. The other 2 had 1 disc and 1 ball. Other than some dried up grease and minor contact wear, they were still in pretty decent shape. After cleaning, I greased them with Krytox. This really is a great multi-purpose synthetic grease and I use it almost everywhere. Now there are some specialty greases that are better for electrical contacts, but for light duty switches like these, Krytox works just fine. And before installing them back in the rig, I set up a quick continuity test to make sure the switching action was working. This one here is the one with 2 contact discs. It worked just fine, so I'll use it for the meter switch because it gets the most use. However, the other 2, the ones with 1 ball and 1 disc, are clearly not switching cleanly. There's intermittent contact when you wiggle the actuator. But no worries, I can still use these in the power and coupling circuits because those only need single pole switches and I can use both poles for some redundancy. Okay, with the socket and switch issues sorted out, it was full speed ahead with the assembly. Alright, I'm through step 24 of the assembly, and step 25 puts a capacitor on the back of the meter, and 26 and so on starts getting into the wiring. So I thought I'd stop for a moment here, talk about a few observations I had from putting the first 24 steps together. One is, can't keep the chassis that clean anymore, getting fingerprint smudges on it. I think that's kind of inevitable, just handling any kind of metal object like that, but no big deal. Still obviously a lot cleaner than it was when I started. And the second, the way that this front panel is held onto the chassis is really weak in my opinion. It's only 2 locations. It's the key jack and the jewel indicator. That's the only 2 places that hold that front panel on. From a mechanical integrity standpoint, that's kind of questionable. I'm not sure why E.F. Johnson did it so simply that way. Normally you're going to find more secure mounting screws or fasteners holding a front panel on, but it's obviously not going to fall off. It did take a little bit of adjustment before I tightened those 2 down to make sure I wasn't shorting out where the crystal or the VFO would plug into the socket, and that the 2 slide switches there still work. So I think it's going to be okay. So at this point I'm going to move forward with the wiring. I just completed step 91 of the 114 steps in the assembly process. And the next step here, step number 92, is installing the power transformer. I thought I'd pause at this point because once I put it in, it's going to get a lot messier and more complicated here. I thought I'd stop and just talk about how things are going so far. So several observations. My method of embellishing the schematic as I go along with embellishing a copy of the instructions is working just fine. It's really been good to help keep track of exactly what components I put on and which ones I haven't. Now, of course, the length of a particular connection on the schematic has nothing to do with the length of the wire. Sometimes, you know, the really longest connections on here are some of the shortest wires, so you just have to be cognizant of that. But other than that, the technique's working okay. Certainly not as elegant of an assembly process as the Heath kits have been. Those manuals are just an order of magnitude better. I mean, clearly they paid their graphic arts people a lot more money to come up with some really good illustrations, as well as a very simple thing. When you go to solder a connection to a terminal, Heathkit was very consistent about reminding you how many connections should be there, because in some cases you might put a wire on a terminal early on and then come back to it later with additional wires and just a final reminder of how many wires should be there so you don't miss one. But other than that, I mean, this is a very simple design, so it's not that hard to keep track of what's supposed to be connected where. And speaking of the wiring, it's just not very neat. There's only so much you can do when you're doing point-to-point wiring. There's not a pre-built, factory-laced, and elegant wire harness to put in, so it's just not going to be to that level of artistic style. But it is, like I say, simple, so I'm trying to adhere to keep the wiring close to the chassis where the instructions say to do so. And then the last thing I would say, if you were paying attention to the earlier video, I did have inductors L1 and L4 reversed. One has one more terminal than the other, so it should have been obvious which one went where. And I caught that, of course, when I started connecting up one of those connections and realized, hey, there's no extra terminal here. So it was not that hard to fix and swap it around and get back on track. Okay, I've completed the rewiring of the Adventurer, so let's take a look first at the bottom of the chassis, and there's a few highlights here I want to cover. First is I did replicate these guys here, which may seem a little unusual, and they are kind of unique. They're hand-wound coils. They're basically there for RF suppression on the power input and then also on the keying connection right here for the CW key. And I did replace the capacitors as well in this circuit for the AC line power feed, and these are safety rated caps. I always do that on all my repairs, to get rid of the old ceramics and put in AC rated caps. And of course you can see it peeking through right here. There is a 3-wire cord now. Now I would have preferred to put a socket for the standard replaceable cord, but there just really isn't room to do that on this chassis, and I did not want to carve it up to try to squeeze it in, so I just went ahead and put in a permanent cord. But I do have what I think should be adequate mechanical strain relief here. I've got a cable clamp around the end of it and a wire tie put on there to help keep it from being pulled out or twisted. So I think this is going to be just fine. I think this will be solid enough. Moving on to the middle of the chassis, pretty much all point-to-point wiring. There's no loom here to make it look neat, so the wires just run as they need to from point to point. I did reuse most of the capacitors, the ceramics, and the micas in particular. There's a couple of ceramics I replaced just because they looked like they were in pretty tough shape. Even though they measured okay, they looked pretty beat up and covered with burnt gunk. But that was the exception. The majority of the caps I just kept in place. However, the electrolytics, of course, those are brand new. I'm putting 2 of them in series on both sides of the choke just because of the voltage rating. It's very expensive to get a cap that's rated for the original voltage rating. And then, of course, there's bleeder resistors in there too to help bleed off the voltage and to balance the voltage on the ones that are in series. And then last thing I talk about here real quick is the original instruction said just use a piece of hookup wire to go from the antenna jack up to the top side of the chassis. I'm using a piece of coax. I think it's much more robust to have that RF power output shielded, and then also it's going right over the DC supply, so having some shielding there can only help things a bit. Top side, there's really not that much wiring up here. A few things you can see, of course, here's that coax coming up the bottom of the chassis up to the tuning cap. On the other side, you can see there's nothing connected right now to this added meter that my dad put in. I couldn't figure out exactly how I wanted to use it, so for now it's just sitting there, and at some point when I look at maybe possible modifications or alterations to the rig, maybe I'll figure out a way to use it. But for now, because there's a hole there, I got to put something in it, so it's just sitting there not connected. Next up, of course, would be to test out the power supply and see if it works, and then if it does, to try to get some power output from this rig. And I did originally intend to include those steps in this episode, but I'm kind of running short on time, and this is a really busy month for me, this October, so I thought I'd just get what I have together today out into an episode and have the power on tests and power tests in the 5th and hopefully final episode for this project. So please stick with me for that episode. I do hope you're enjoying this material, and until next time, bye for now.